Before the video starts, we've had quite a few people reach out and ask how they can help support our Not a Wheelchair project. And I finally have an answer. We are selling these coins with 100% of the proceeds going towards making our accessible equipment cheaper for people who need it. But more on that at the end of the video. Behind me is the largest and most powerful and most useful tool I have ever owned. Hidden inside of this box is the mechanical ability to morph solid blocks of metal into useful prototypes. Where science and magic meet and where digital space meets physical space. Our goal here at Not a Wheelchair is to make inexpensive, non-medical accessible equipment. And we've accomplished a portion of that goal with the rig, which has half the price and twice the spec of any other off-road wheelchair out there. But we also have quite a few other projects in the works, one of which involves longboard motors and tank tracks. The inexpensive longboard motors are built for speed, so we have to create a custom gearbox that will lower the RPMs while increasing the torque. But lucky for us, the exact tool that we need to manufacture and prototype that gearbox is sitting inside this crate. And today we're going to unbox it and try it out for the first time. Let's get started. I've wanted one of these machines for years now. Being able to take a digital design and bring it to life in the real world ourselves in just hours is a huge deal. Here at Not a Wheelchair, we are designing and manufacturing inexpensive, non-medical accessible equipment. And being able to prototype stuff with hardly any downtime is a huge game changer. And I'm super excited to be working with Tormach. I'll get more into how everything works in a minute, but basically this Tormach 1100MX is the exact opposite of a 3D printer. If you remember, a 3D printer creates something from nothing, called additive manufacturing, like that giant statue I made of myself using a 3D concrete printer. That 6,000-pound statue I left in Dad's backyard is still there, by the way. He either really likes it or has no idea how to get rid of it. Could be either one. But yeah, instead of creating something from nothing, this CNC milling machine can take a solid metal block and cut away the parts we don't need to make something useful, also called subtractive manufacturing. And with the doors open for the first time, we can get a look at the pristine machine before chips start flying. Of course, we can't get down to business without running some tests. We'll start with something called a miller's cube, and we'll make it out of a solid block of aluminum. It'll also help us make a pretty good comparison between milling machines and 3D printers. We'll be making the exact same miller's cube with a 3D printer, so we can see how each machine accomplishes the same task differently. As you can see on the printer, we start from nothing, and each line of the cube is added, one on top of the other, with temporary supports helping keep the arcs supported. With our Tormach 1100MX, the solid aluminum cube is rotated and precisely milled on each side, removing or subtracting material with each pass to reveal the design we've digitally mapped into the machine. Both shapes were obtained from different processes, made out of different materials, but are both useful in their own ways. Different machines for different things, and the more tools we have on hand, the better able we are to make cool stuff. I'm mostly making this video so I can talk my wife into letting me buy more tools. Speaking of which, while this has all been fun, let's get into some actual work with the Tormach. We're going to turn this slab of metal into a gearbox, and it should be pretty interesting watching it happen. To slice the stock in half, we are using a milling bit, moving in a helical pattern as it passes through the center of the aluminum. Inside the chuck right now we have this sensor which helps us find out where exactly the metal is positioned. We'll clamp it down in a second. And then we have 8 tools in the automatic tool changer which lets the whole process happen automatically. Now that we have it cut in half, let's watch this be turned into a gearbox. Fixturing is a huge part of milling, as we found out the hard way here in a second. Clamping down and holding the metal to the table is extremely important. If the workpiece moves or pops out, the whole milling process can be ruined. The large 3-inch shell mill took a very thin layer off the top, giving it this mirror finish and squaring it so everything matches up as we mill the rest. The next step is a 1/2-inch solid carbide drill, making a hole through the gearbox so we have somewhere for the shaft to exit. We are currently working with aluminum, but this Tormach can also mill steel, titanium, and plastics, all by just switching out the tooling. After drilling the hole, we switch over to a 3/8-inch end mill, which is just like a drill bit, but instead of cutting straight down, it can also cut on the sides, removing quite a bit of material as we carve out the inner portion of the gearbox. In order to help with the cutting and prolong the life of our tools, we are flooding the workspace with coolant. If the bits get too hot, they might break or warp. And if the metal we are cutting gets too hot, it kind of starts melting into itself and stops cutting cleanly. So the coolant is pretty important. The white milky coolant also helps move the chips away. After hitting the workpiece, the coolant flows down into the base of the Tormach and then gets recirculated through the pumps over and over again, just like the liquid cooling in a computer or a vehicle. All while the metal shavings get caught on a mesh so they can be pulled out and recycled later. With our inner cavity and gearbox milled out, our tool starts milling out the outer edges, revealing the exterior shape. The 1100MX is revealing the structure of what we digitally programmed it to do. Milling is a lot like archaeology if you don't think about it very hard. So remember, I'm not a professional in any of this, but that thing does look pretty darn amazing. You can see the tool paths all being CNC'd out of the metal. This used to be a solid block, and now we have room for some gears. If you notice, these markings are the same milling patterns we see inside of cell phones, since most smartphone housings are very precisely milled to the exact specifications, using similar machines to this one, just much tinier tools. Now that we have the shape more or less in place, we have to switch to a smaller end mill so we can get more of the detail milled out. With the parts milled, drilled, and topped, we can remove the part and flip it over so we can complete the backside. This is where things went a little haywire, since our clamping and fixturing game isn't quite optimal just yet. It took us a few tries to get this right. Now that we have the material set and clamped, throw on a new end mill, and it should just trim off around the edges. Gotta get those clamps on there. Dang, could have been worse. Could have been worse. Round 2. We gave up trying to clamp the workpiece directly, and instead made a fixture plate with some mighty bites, hopefully getting a mightier bite on the gearbox. But it should work this time. Oh, that scared me. When in doubt, just get a bigger vise. Now for Second try. Finally, combining a new massive vise and the fixture plate as our reference point, whoa, with some absolutely delicious resonance frequencies, we finally finished the gearbox housing. One half of the gearbox is now complete, not bad for 2 tries. But I've learned that the first step to being really good at something is being really bad at something, and practice makes perfect. Now let me show you what this is going to be used for. This gearbox is designed for a custom 10-to-1 gear reduction. I can't talk too much about the final product just yet, gotta wait a little bit longer for that one. But you can hit the subscribe button so you don't miss when that comes out. Basically, the gears allow us to reduce the top speed of an electric longboard motor by 10 times, while increasing the torque, or strength of the rotation, by 10-fold, allowing us to do some pretty crazy things. The internal gears of the box are currently prototyped from plastic, just to see if they would fit, but we have metal gears planned for the final version to again increase the strength and long-term durability of the accessible equipment that we're making. Metal handles torque better than plastic, and I'm super excited to show you what this is for very soon. The learning curve with this new toy has been super fun, and huge thanks to Tormach for their assistance and expertise getting it all set up. Our whole goal here at Not a Wheelchair is to manufacture inexpensive pieces of accessible equipment, and huge thanks to Tormach for jumping on board and assisting us with that dream. I'll leave a link for Tormach down in the video description if you're curious on pricing or any of the other awesome automated tools that they happen to be selling. They might have something that's useful for your own projects. I know there's a few more that I have my eye on. Which brings me to the last thing we're going to be milling today, the coins. Also, Cambry's back.
It's my turn to do some narration. Because the coins are so small, they need their own fixture. We're going to start with the 2-coin fixture, which has a cavity milled out and some holes tapped. For the Mighty Bites. I'm sorry. Mighty Bites. Is that the word?
The Mighty Bites.
The Mighty Bites. The Mighty Bites are the bits that clamp the coins.
Remember, Cambry and I aren't taking any profit from this Not a Wheelchair project or a salary. We make money elsewhere. Any money made here at Not a Wheelchair goes right back into the business to make accessibility cheaper for everyone. It's kind of important to us.
However, the more help we can get, the more people we can hire, and the faster we can make and manufacture our ideas. And to do that, we've made a 2022 Not a Wheelchair collector's coin right here with the Tormach 1100 MX.
Nailed it. 100% of every donation goes straight into the business, helping keep prices low, the lights on, and digital designs turned into realities.
We aren't like insurance companies. We're not trying to make money off of people in wheelchairs. We are trying to manufacture and sell our stuff as cheap as possible so that we can get it to those people that need it most.
Even just watching and sharing this video is a massive help, but if you do happen to have a few extra bucks, getting a coin will go a long ways towards making inexpensive accessible equipment a reality. 100% of your donation stays right here in the business.
You can get 1 for 15 bucks, 5 for 50, or if you're feeling real generous, 10 for 100 bucks. Every donation will go a long ways, and we appreciate it so much.
The 2022 Not a Wheelchair coin will only be available this year. We'll probably come up with a new design for next year, so get it while you can.
And if you get one in the next week, we'll send a hand-signed thank you note from us.
And of course, let me know down in the comments if you want to see behind the scenes how we manufacture all of these things as we progress.
I feel lucky being able to see it up close and personal.
Coming out with us on Instagram and Twitter if you haven't followed us already.
Thanks, Dan, for watching. We'll see you around.